Welcome to All Things Photonics, a podcast about the physical science of light driving scientific innovation in the 21st century. I'm Joel Williams, Associate Editor at Photonics Media. Join us as we explore the latest trends in optics, lasers, microscopy, and spectroscopy. Each episode, you'll hear from leading voices from across the photonics landscape, brought to you by Photonics Media. Through our first 3+ seasons, All Things Photonics has taken listeners to all corners of the photonics industry landscape. If we've learned anything in 32 episodes, it's that the industry is distinguished not only by innovation, but by the trends that impact the supply chain and research and development pursuits, as well as the global science ecosystem. In few areas is that two-way street of influence more evident than it is in the booming Lidar sector. The technology has positioned itself at the forefront of technological advancement in applications ranging from autonomous mobility to seismology. Its ascent has been diverse as it has been rapid. 2 years ago, Applied Market Research valued the global Lidar market at greater than $700 million. Growing at a compound annual growth rate in excess of 20% for the period of 2020 to 2027, the agency predicted last year that the market would grow to a nearly $3 billion industry by 2027. This year, Global Market Insights revealed its estimate that the market for LiDAR will surpass $7 billion by 2027. Quote, "The rising adoption of LiDAR technology for advanced mapping solutions across multiple applications is expected to contribute to the market growth," the firm said. The statement supports the durability of the technology and its variations. These extend well beyond applications aimed at autonomy. Durability and variety are excellent characterizations for our featured guest. From his time at Newport Spectrophysics and later at Ocean Optics, the name Jason Eichenholz grew synonymous with innovations in commercial laser optics. Eichenholz is active in photonics outreach, education, and research and development. He holds more than 50 patents and is a leading presence in the ever-growing world of photonics entrepreneurship. 9 years ago, Eichenholz co-founded Luminar Technologies. As CTO, he helped take the company public late in 2020. Following its arrival in the marketplace last December, Forbes tagged Luminar CEO Austin Russell as officially the youngest self-made billionaire. LiDAR may be a trend, but it is hardly a fad. LiDAR has arrived on the scene both within the scope of optics and photonics, and for Eichenholz. His path to Luminar, as well as his influence in and beyond the technology, is the focus of our interview. Our conversation begins in the year 2012, the literal formative year of Luminar Technologies. Here's Jake Saltzman with Jason Eichenholz.
So certainly you are an accomplished photonics person, right? You've done a number of things in the field, both entrepreneurially and technologically. What prompted you, Jason, to enter the LiDAR space and ultimately to do so in the form of forming a company?
Well, we were looking at a bunch of different options. I had my company Open Photonics at the time, and we were looking at things, and I had met Austin Russell when he was in high school. And he was looking at all sorts of 3D sensing modalities and markets for it. And I was looking at it as well. And we were doing projects in cancer detection. But eventually we saw this unmet need with LiDAR technology. And we saw the legacy incumbent technology with the spinning Kentucky Fried Chicken buckets up on top of the cars, spinning around at 360 degrees, and thought there's got to be a better way to do this, make it more cost effective, and realized that essentially, the entire industry had not matured or advanced at all in 10 years. And when you see a decade of time pass with no technology innovation, you know it's a great market to go jump into. And, we were looking at the autonomous vehicle space and self-driving cars. And, we've been looking at self-driving cars before self-driving cars were a thing. So it really gave us a really first mover advantage to get the technology architecture done the way we wanted to get done, and simultaneously get the intellectual property moat around what we were doing done very, very effectively. So we just got our 100th patent in the company a few months ago. So between those two of those, the timing of what we did, how we did it, it ended up being quite fortuitous for us.
That's right. So when you're starting a business, obviously any kind of business, there are those logistical challenges, and then you factor in the technology and wanting to not get it off the ground, but accelerate it and do it your way, do it the right way. Let's look at some of the challenges here, because there are some with any technology. When you formed Luminar, how familiar were you with some of the distinct challenges that were facing the technology? And, I'll talk about eye safety and all weather amenability, some of those core challenges that remain sort of topical. How familiar were you with them?
So we were actually very well positioned to understand those challenges. So being here in Orlando, there's a lot of military and defense work that goes in to the eye-safe LiDAR at 1550 nanometers. And, this is a Photonics podcast. So, we're at 1550. We're at 1550 because that's where the telecommunications laser sources were.
That's right.
And that's where allowed us to hit economics and to leverage that infrastructure. We could have been anywhere in the eye-safe region. We could have been from 1400 up to 1600. And you got to look at where InGaAs as a receiver material works as well. 1550 just made sense. And it made sense because of that eye safety and that inherent eye safety where you had, a factor of 10 in laser power. And what a lot of people don't recognize is a LiDAR system, when you design the technology and you make it really, really good. And we build our system from the chip level up. When you do so and you're optimizing every single component rather than buying something off the shelf, when you optimize everything, photons matter. We say our system has a photon budget, which everyone in this industry knows. Photons are critical, and you're counting photons. And so that 10x power advantage, when you jump from 905 nanometers to 1550, actually is a 17x advantage. A lot of people didn't quite understand that. But the eye safety, the inclement weather, the weather adaptability, all those things are things that I had done and the team had done for decades. And we had done at Ocean Optics with remote sensing and other companies. It really wasn't that big a leap for us to make that jump.
We'll talk about Ocean Optics. We'll talk about Newport Spectrophysics in a moment. We may even talk about Orlando. You did mention being in the Orlando area, but staying in the technology here, how far has it come in your estimation? You're familiar with it in the last 5-10 years in terms of it now being able to overcome some of those challenges. And I mentioned eye safety, but also the detector technology itself, and certainly moving towards this path of commercialization, commercialability. How far have we come?
We've come a long ways in the last decade or so. I mean, when we started at 905 with silicon with everybody else. And we did the math and we did the numbers and we did the eye safety calculations. And we knew we wanted that 10x advantage in order to be able to see dark objects like tires on the roadway 200, 250, 300 meters down the road, or you're going to be photon starved. You need every photon you can. And being able to start with 17x the photon budget is an unfair advantage. Now, everybody had sworn off for anything except for military, the 1550 eye-safe region, because you needed an InGaAs detector. And everyone said, oh, they're too expensive. They're thousands of dollars. And I had done spectroscopy. I mean, we had bought at Ocean Optics, we bought linear arrays from Hamamatsu or Sensors Unlimited. And, we knew how these long arrays were out there and how expensive they were and the yields. But the reality is you just needed a small, tiny piece of InGaAs. That InGaAs converts from photons to electrons. Everything after that is done in silicon. So we have this hybrid silicon InGaAs receiver. And the InGaAs is produced by our company that we just acquired, Optigration. And they're in Boston. And all of the ASICs are designed by our Black Forest engineering team in Colorado Springs. So between the guys up at Optigration and the folks and the whole team at Black Forest Engineering, Colorado, we have this unfair advantage on economics and performance that is unprecedented. And that didn't exist prior to Luminar.
So you talk about an unfair advantage. I think I will call this a fair advantage. It involves your experience in industry, Newport Spectrophysics, Ocean Optics. And when you're talking about LiDAR, you are talking about, at least tangentially, all these other technologies, right? You mentioned detectors, spectroscopy. Certainly you come from a background that's heavy in spectroscopy. You have to have an eye on the supply chain for materials. How has your experience in industry and even your experience at UCF Creole enabled you to really hit the ground running and take off with Luminar?
From the time I was a even in undergrad, I knew I wanted to go the commercialization route. And I knew as an entrepreneur, I liked the business side of things. Having had that experience at Newport in spectrophysics and learning what it took to ship a product, to ship a laser, to understand outgassing of onto crystals and the UV, learning from a lot of great mentors, and then doing it again at Ocean Optics, where we were shipping products to the bottom of the Marianas Trench, top of Mount Everest. We were shipping products that were going to the moon, 3 spectrometers running around on Mars. You learn how to develop stuff for some pretty tough environments. Now, the automotive environment is even worse than having to put something on the space shuttle or on a rocket. You've got the shock and vibe and the temperature and the humidity and all those things. All of those came together in a really unique way when we started designing systems. And the first systems, they kind of looked like military systems. But as we took the millennia of man and women years of experience with Lidar technology, added the incredible engineering talent out of places like GoPro and Motorola that allowed us to have that consumer electronics, and now the automotive industry experience, now you're getting something that's auto grade. Now you're getting something that can be scaled to hundreds of thousands or millions of units a year, and leveraging our manufacturing partners. So all of that came together with an eye of you got to design it once and it's got to work at the same time.
In March of this year, SPIE announced a new Photonics Technician Scholarship in Jason Eichenholz's name. The scholarship is funded principally by Eichenholz himself. Its origins stem from interests that are personal as well as professional. Our interest in the Eichenholz SPIE Photonics Technician Scholarship segued into a conversation about the lack of qualified technicians in optics and photonics, which is hardly a secret. The impact of that trend holds industry implications for today and possibly for tomorrow.
So being an entrepreneur and playing in the spaces in which you get to play, it lets you do some pretty cool things, I don't want to say on the side, but in addition to the work you're doing. And one of those is it's the SPIE Photonics Technician Scholarship in your name. What are some of the trends, either ongoing or previous, that inspired that scholarship, and what's its aim?
Early in my career, when I worked in a summer internship at IBM, and I recognized the immense value of technicians to go in and build things and do things, and the hands-on skills. And I grew up in a garage. I love working with my hands. But also recognized that there's a role for technicians. And that really came home when I was at Ocean Optics, and I had some incredible technicians that were working for me in both R&D and on the production floor. But these technicians are incredibly difficult to find. And I think it's the lack of trained technicians really stymies the growth of the industry, because we don't have enough people willing to kind of go get their hands dirty and go work in the lab or on the manufacturing floor. And I was also motivated by a meeting I had. I got a chance to meet with Mike Rowe in Rowe Works, and he does a lot of great work on creating, technician type jobs for people. And between those two things, and then the last thing was early in the development of Luminar, we were struggling just to find people. A lot of the time we were in stealth. So for the first 4 years or so, we didn't even have a website. And you're trying to hire engineers or hire people. And we created a program, or we participated in a program where we were hiring disabled veterans through a job retraining program. They were mainly electronics technicians, and then in-house training them to be photonics technicians. And that was incredibly rewarding. And I thought after we had our success in December and were listed on NASDAQ, I thought, what a great way to give back to the industry that was so good to me, but to do it in a way that most PhDs wouldn't think to do it. Do it in an area that really would meet the needs of the industry and allow the industry to grow the way I hope it does.
In the optics technician world, right? It's almost like an onion, right? There are a lot of layers to it. There's a shortages problem. There's, how do we create the curricula? How do we deliver the curricula? How do we fill this need? How do companies bypass the need to train once they've hired, right? There's a lot going on there. From where you sit now, not just at Luminar, but as someone who knows this industry really well inside and out, how prominent of a problem does that remain?
It's a huge problem. The lack of technicians will influence and affect the ability of some companies to deliver on products. I have a friend of mine who's got a company, and another passion area for me is special needs. I have a special needs son with autism, and he's hiring a technician who does incredible work loading prisms with a young lady on the spectrum. She's a little different. She needs a little bit more help and hand-holding, but she does superhuman work in attention to detail. And if you can find great technicians that can do the work needed, the entire industry will grow faster. If not, we're going to be stymied in what we do. I think it's one of the biggest challenges in the industry is the workforce development of technicians.
When Luminar announced its plans to go public earlier this year, it wasn't the first LiDAR firm to do so. Velodyne LiDAR debuted in the marketplace in September 2020. Additional companies including Ouster, Septon, Ava, AI, and Innoviz have either joined their competitors as publicly traded entities or announced plans to do so. These companies share more than residence on Wall Street. Each has joined forces with what is known as a specialty purpose acquisition company to become publicly traded. That trend, increasingly specific to LiDAR companies, is unmistakable. As our conversation shifted back to Luminar and the LiDAR industry, we asked why.
Want to move back to talk about a company in Luminar, especially. One of the things that companies do is they go public, right? And there are a number of ways to do that. And one of the things that has become really a full-fledged trend in the LiDAR space is going public via SPAC mergers. It's something it's so prominent now that it's caused us to take a step back and look at why this is happening and why it could happen. So I'm going to ask you that. Why have SPAC mergers taken off and so suddenly?
From the beginning, we set the company up to go public. From the early days, the Teal Fellowship that Austin had to going, many companies in the space set themselves up for acquisition. But we knew that we wanted to be more like Switzerland. We wanted that in order to make autonomy safe and ubiquitous. We didn't want to be beholden to any one company and their product development timeline. We are on the precipice of a huge, huge change to transformation. I was saying, this is the single largest change in transformation to transportation since the Model T. And so we knew in order to make autonomy safe and ubiquitous, we'd have to scale the company into working with every major player in order to see this through. That was the path that we were on when everything culminated at the end of the year with us going public. That route accelerated our time frame. It made sense for us based on the technicals, milestones we were hitting, the engineering progress, the execution, and of course the deal pipeline. And that deal pipeline as a mechanism to then going public, it was just like the perfect timing. And so now our execution is putting us with some of the best performing companies in the industry.
And there are a number of companies in the industry, and everyone does something a little different, right? Or they do it a little bit differently. They don't all own their own chip supplier. So what made it the right time to make the Optigration purchase and move the business forward that way?
So Optigration was a company we had a long 5-year history of working together with. Great partnership. As we were getting into production, high volume production, and beginning to ramp the Iris, we took a really good look at the entire industry. We also looked at supply chain and knew we didn't want to be beholden and stuck in the same pipeline as everybody else. We wanted to take control of our destiny, and we had worked out what that acquisition would look like with Optigration years ago. And with the liquidity that came with going public, it just made sense. And we weren't in a rush to do it, but we did it in a way that made sense. And the timing was ideal. And now that they're part of the Luminar family, combined with the Black Forest engineering team, we're really in a great position for growth and scaling.
The industry itself is growing. I wouldn't call it a linear growth, but you're better off to make that characterization than I am. My question is, are we at or are we approaching a point of consolidation? And really, are we at that point considering the number of LiDAR developers and deployers in the market?
When we started, there were a handful of LiDAR companies out there. And, I hear numbers over 50. I hear numbers of 100. I hear all sorts of numbers on it. And I think we are absolutely at the point of consolidation. There's no question that the number of LiDAR companies, especially some of the small venture capital backed companies, are now recognizing that there is an incredible amount of CapEx and personnel investment required to address the needs of the automotive industry. You don't get to make a widget. You don't get to make a laser diode chip and say, okay, here you go. You have to make the entire system. And the entire system needs to be put together in such a way that it meets the automotive qualification of IATF certification. You need to get your processes in place. You need to build your engineering validation. You need to validate the design. You need to go through production level testing. And it is a huge investment that frankly, as someone who sent something up into space, who's someone who had mil spec products shipped around the world, and as someone who's gotten two devices certified by the FDA, I grossly underestimated the amount of effort required to meet the needs of the automotive industry. It's sort of all of those combined together on steroids, to the 10th power. That effort is huge and capital intensive. And what's happening, and we're seeing it now, is companies that are going to raise the next round their investors are realizing just what it takes to go do this. I think it's going to be very natural to see a lot of consolidation and acqui-hires over the next 1 to 2 years.
Facts and Figures research estimates that the global autonomous cars market size and share revenue will grow to nearly $65 billion by 2026. In a report this summer, the company broke down its estimation into component types, with LiDAR first on the list. As we mentioned, the technology of LiDAR literally extends beyond the roadway, into the sky, underwater, and underground. Eichenholz holds a perspective on the technology that is more personal. He shared that perspective with All Things Photonics and gave his 5-year forecast for the field.
And one of the things we tried to do with this interview, and there are two of them. One is talk about your photonics background and why you're so uniquely well equipped to be in the position you're in now. The other one was that we wanted to make this a LiDAR interview and not an autonomous driving or automation interview, right? Because there are other drivers. It's a bad pun, but there are other drivers for LiDAR. And we've talked about gas mapping LiDAR recently here at Photonics Media. To what extent was autonomous driving and really all things vehicles a driver for you in Luminar?
So for me and Luminar. So for me, self-driving is very personal. So I have a 14-year-old daughter. Like most dads with 14-year-old daughters, the last thing you want is your daughter to go driving. But at the same time, I'm kind of looking forward to teaching my daughter how to drive and teaching her how to go drive a manual transmission. But not wanting my daughter to drive is more of a want. I also have a 16-year-old son, Jonathan, who has autism. I don't know if he's ever going to drive. But to be an active, productive member of society, he's going to need safe and ubiquitous transportation. And as I've looked into this, I've recognized how big a challenge this is, whether someone who's visually impaired, someone who's got developmental disabilities like my son, or other mobility challenges. And I see the opportunities that automation, autonomy, self-driving cars can provide as a real life changer for people in terms of their ability to have freedom and move around. The same thing goes for elderly people and people who maybe shouldn't be driving, but are. I mean, I'm in Florida, we're the capital of this, right? So again, if we can give people the ability to have mobility and transportation, maybe they can stay in their homes for a few more years. That would be a great thing to do. Knowing that challenge and making it personal, I think everybody should sort of have something that motivates them and drives them to go do this, which is why this is so much bigger than just a job or a company. This is literally changing people's lives. I look forward to being able to have autonomy in cars driving that are able to provide this level of service. And so it's very personal for me.
And one more, Jason, before we let you go. We talked about where we were, where we are, where we're going, but I want to put you on the spot even more with in terms of a forecast for LiDAR. Take me back to 2017. What was your 5-year forecast then? And then second part of that question, what's your 5-year forecast for the technology now?
So, 2017, we knew it was a big market, and we were just trying to make it work and trying to make the eye-safe LiDAR technology work. And really what that meant was the technology work was getting it to scale and production into scale. I think what you're going to see is there's a lot of trends in alternative materials. There's a lot of things going on with laser diodes and high brightnesses. But what I like to see is that having inherent 3D sensing on cars from LiDAR that has the ability to have the spatial resolution as well as the range, so points per square degree range. So not only do you know that something's there, but what it is, it will unlock the next generation of vehicle safety. So when we talk about proactive safety, and also unlock autonomy. So over the next, as we come out of 2021 and we're looking at 2026, you're going to start seeing highway autonomy. You're going to see LiDAR being much more ubiquitous in all sorts of sensing and transportation modalities. And that's a future I'm very much looking forward to.
That concludes this week's episode of All Things Photonics. Thank you to our engineer, Alan Shepard, and to our news editor, Jake Saltzman, as well as to this week's sponsors. Our featured music is courtesy of betterwithmusic.com. Most of all, thank you, our listeners. As always, you can share your thoughts, pitch us ideas, and let us know how we're doing. You can reach us at allthings@photonics.com. All Things Photonics is available on all major platforms, including Spotify, Apple Podcasts, as well as on our website, photonics.com.